When discussing hyperbolic functions, we have to go through a couple of aspects of the functions. The domain is such that it excludes the asymptote. It has to exclude the asymptote, so all x values are acceptable except at the asymptote. The range excludes the asymptote, the horizontal asymptote as well. And the standard form of the hyperbolic function is y is equals to a over x minus p plus q, where this p and this q are the asymptotes. Here is an alternative form, but this one requires more algebra to simplify that. The a determines the quadrants in which the function is sketched. The xy Cartesian plane is subdivided into 4 quadrants. If this a happens to be a positive, if it happens to be a negative, then the function is increasing. And the function is in quadrant 2 and 4. If a is positive, then the function is decreasing. And the function is placed in quadrant number 1 and 3. This is the scenario whereby a is positive, this being quadrant number 1, quadrant number 3, quadrant number 2, quadrant number 4. And the broken lines there, it's not the xy Cartesian plane, these are the asymptotes. So this is the vertical asymptote, which is otherwise known as the x asymptote. This is the horizontal asymptotes, otherwise known as the y asymptote. Q, which is the y asymptote, is otherwise known as a vertical translation, where you move the graph either up or down. If you move the graph up, that's a positive. You move it down, that's a negative. P is the horizontal translation. You're shifting the graph either to the left or to the right. If you shift it to the right, ironically, you're shifting it in the negative direction. If you shift it to the left, you are shifting it in the positive direction. If equations of asymptotes are requested, then the first one is y is equals to q, which is just the vertical asymptote, the horizontal asymptote, and x is equals to p, that is the vertical asymptote. Axes of symmetry, there are 2 of them, hence the plural axis of symmetry. There is one that comes with a negative gradient, and its equation is governed by y is equals to minus x plus p, the x asymptote, plus q, the y asymptote. The other one with a positive gradient is y is equals to positive x minus p, the x asymptote, plus q, the y asymptote. Axes of symmetry are perpendicular to each other at the point of intersection. The next aspect we need to discuss is the sketching of the hyperbolic functions. When you're sketching the hyperbolic functions, examiners look at 3 things. Number 1, did you indicate the asymptotes? Did you show the x and y intercepts? And lastly, the shape. The shape is governed by the quadrants. So the third aspect is the shape, and the shape you can find it from the A. And A will tell you quadrant number 1 and 3 or quadrant number 2 and 4. How do you determine the equation of the function? The number of unknown variables. Any one of these variables, A, P, and Q, can be unknown. Ordinarily, it depends on the number of pieces of information, the amount of data that you're given. They give you 2 points, then probably you have 2 unknowns. 3 points, then you have 3 unknowns. The next aspect is graph interpretation, and this will help you when you're determining the equation. Transformations, this is shifting the graph right or leftwards. So if you're going left, it's positive. If you're going left, it's positive. And here's an example. Shifting the graph 2 units to the right. 2 units right will come out as f of x minus 2. If you're shifting the graph 5 units left, then it's as good as f of x plus 5. Conversely, you can shift the graph up or down. If you're shifting it up, it's a positive. If you're shifting it down, it's a negative. An example of which is shifting 4 units up is going to be written as g of x plus 4. And shifting 10 units down is going to be written as h of x minus 10. Those are the transformations. Now we have exam type questions, examples of exam type questions. The first one that we're given is f of x is equal to minus 3 over x plus 1 plus 5. If you analyze this before you do anything else, take time to analyze what is given. What are we given? A is equals to minus 3. What else are we given? We're given x plus 1. This is in the denominator. This will assist with giving us the value of p. Therefore, x is equals to minus 1. Therefore, p is equals to minus 1. P is equals to minus 1. And consequently, y is equals to 5. Therefore, q is equals to 5. Those are the 3 aspects of the graph that we are told in the equation. We are told that a is minus 3. We deduce that p is minus 1. And we are also deducing that q is 5. So, that is the question where they say, given f of x is minus 3 over x plus 1 plus 5. Write down the asymptotes of f. That's the first question. Write down the asymptotes of f. 5.1. 5.1. The asymptote is x is equal to minus 1 and y is equal to 5. Those are the asymptotes of f for the first part of the question. It's 2 marks because it's a mark each for the asymptote of x as well as the asymptote of y. The domain, that's 5.2. They request the domain for 5.2. Earlier on we said if you are looking for the domain, you are going to exclude. You're going to exclude the x asymptote. So for the domain, it's x not equal to p. X not equal to p. Our p is minus 1. Therefore, domain is such that x in real, to take all the values in real numbers, but it will not take minus 1. So x not equal to minus 1. It will not take x is equal to minus 1. That is what we were saying earlier on. Going to the next question. That is 2 marks there. 5. That was actually 5.1.2. So this is 5.1. 5.1.1. The next question. Calculate the intercept of the graph with the of f with the axis. So they need an x-intercept as well as a y-intercept. So 5.2. X-intercept. This is the English. What is the corresponding math? The corresponding math is y is equal to 0. You go back to the equation, wherever there's y, you put 0. This comes out as 0 is equal to minus 3 over x plus 1 plus 5. In this equation, I've substituted y is equal to 0. Transpose the minus 5. Minus 5 is equal to minus 3x plus 1. Algebraically, you can just interchange the denominator and this value on the left hand side. So it's x plus 1 is equals to minus 3 divided by minus 5. This comes out as x plus 1 is equals to positive 3 over 5. Which means x is equals to minus 1 plus 3 over 5. Therefore, x is equal to minus 2 over 5. The corresponding x-intercept is minus 2 over 5 for x and 0 for its y. 2 marks for that. Where are the marks? Substituting 0 and the actual value of x minus 2 over 5. If we require the y-intercept, then x is equal to 0. This is the English, but this is the actual math. In this equation, wherever there is x, you're going to substitute 0. So that means y is equal to minus 3 over 0 plus 1 plus 5. Y is equals to minus 3 over 1 plus 5. Y is equals to minus 3 plus 5. Y is therefore equal to 2. The corresponding point, the y-intercept is 0 for x and 2 for y. 2 marks also. Where are the 2 marks? The substitution for 0 and the final answer. That answers question 5.2. Sketch the graph of f for x greater than minus 1 in your answer book. Clearly show the asymptotes and the intercepts with the axes. They say starting from x is equals to minus 1, 0, 1, 2, 3, and so forth. 1, 2, 3. Y, x. We start by drawing the asymptotes. These are the asymptotes. So you draw the asymptote at x is equals to minus 1. The asymptotes are drawn as vertical broken lines. At the bottom of it, you write x is equals to minus 1. The other one requires y is equals to 5. So let me change my scale to be able to fit it in. This is going to be 2, 4, 6. 2, 4, 6. Here is 5. 5 is right here in between 4 and 6. Y is equals to 5. A is negative, so your graph is in the 4th quadrant. The graph is in the 4th quadrant and the 2nd quadrant. Before I sketch it, let me point out my x-intercepts. The first x-intercept, my intercepts, the first one is at 2. 0 for x and 2. And between negative 1 and 0, that's where we'll get negative 2.5, which is somewhere here. So the resulting graph is going through those points. There's a mark for shape, so ensure that you get the shape as accurately as you can. That's the graph of f. What do they give marks for? Marks are allocated for shape, intercepts, and asymptotes. Marks are allocated for shape, intercepts, plural, intercepts, and asymptotes. Moving on, the last aspect, this was question number 5.3. The last aspect they require is the transformation. The graph of f is shifted 3 units to the right and then reflected in the x-axis. Shifted 3 units to the right and then reflected in the x-axis. If it's a reflection in the x-axis, then y is made negative. So 5.4, f is shifted 3 units to the, and write down the equation of h. So h of x is equals to f shifted 3 units to the right. This is how you would write the equation. Shifted 3 units to the right and then reflected in the x-axis. This negative indicates the reflection in x-axis. This minus 3 indicates horizontal shift. Three units right. So they want the equation of h. Therefore, h of x is equal to minus 3 minus 3. I remove this x and I put x minus 3 plus 1 plus 5. Then thereafter, everything is multiplied by a negative. H of x is equal to. Therefore, h of x is equal to a positive 3 divided by x minus 2 minus 5. So you have to be able to interpret these aspects. The negative implying a reflection in the x-axis and the minus 3 indicating a horizontal shift 3 units rightwards. That's the first question that we've attempted. Let's look for another one. This is coming from Mpumalanga Prep 2017. Let's attempt this question. From Eastern Cape 2017. Okay, so here's another question. It's still on the hyperbolic function. A sketch of the hyperbola f of x. In this one, it's not given in our ordinary a over x minus p plus q format. It's not in the standard format. So we first need to deduce what this d is, what the p is, and put it in the standard format. Where p and d are constants. The dotted lines are the asymptotes. Full stop. That is a hint so that you can deduce what points those are. The only asymptote we can deduce there is the vertical one, which corresponds to P. So the vertical asymptote corresponds to P. Therefore, P is equals to 2. P is equals to 2, and to assist us with finding D, we're given a point which is 5 and 0. Given a point 5 and 0, determine the values of D and P. So P we already have is equals to 2. We deduced it from the graph. How did we deduce it? P corresponds to the vertical asymptote, which is otherwise known as the x asymptote, which is 2 there. Then that means we have y is equals to d minus x all over x minus 2. we substitute this point. The 5 is the corresponding x, the 0 is the corresponding y. So remove y, put 0, then d minus the corresponding x is 5 over 5 minus 2, 0 is equals to d minus 5 over 3. Multiply either side by 3 to get rid of the denominator, and we'll have 0 is equals to d minus 5. Therefore, d is 5. So we have deduced both p and d. So the equation becomes y is equals to 5 minus x all over x minus 2. Show that it can be written in this format. When you want to change it from that format to the standard format, you can use long division and say x minus 2 into 5 into minus x plus 5. X into minus x is minus 1. That's the quotient. Back multiply. Minus 1 times x is minus x. Minus 1 times minus 2 is positive 2. Step number 3, subtract. Minus x minus minus x. That's a leading 0. 5 minus 2, that's a 3, which is the remainder. Therefore, 5 minus x over x minus 2 has got a quotient of minus 1 and a remainder of positive 3 over x minus 2, as is required. Alternatively, you can use an algebraic manipulation, which is to say y is equals to 5 minus x over x minus 2. This can go there, so you're going to say this is minus x minus 2. This will give a negative x, then this will give a positive 2 plus 3 all over x minus 2. This leaves us with a negative 1 because it's going to be minus x minus 2 divided by x minus 2. You are sharing the denominator plus 3 over x minus 2. Final answer minus 1 plus 3 over x minus 2, which is 3 over x minus 2 minus 1, as required. Long division is much simpler, and it will also help you with your calculus. Factor theorem, remainder theorem. Write down the image of A if A is reflected about the axis of symmetry. Write down the image of A if A is reflected about the axis of symmetry. A was given as 5 and 2. 5 and 0, and it has to be reflected in the line y is equals to x minus 3. In the instance of this, this will be transformed to A prime after the reflection, and that means to find the y value, we're going to say y is equals to 5 minus 3 because the value of x was 5. So the y value becomes 2. To find the x value, you rearrange this and say x is equal to y value plus 3. Therefore, x is equals to 0 plus 3. So the corresponding x is going to be 3 and 2. What did you have to do? You have to rearrange the formula. So to get the corresponding y value, you have to take the x value and subtract 3, which is what I did. This would have given you just 2. Hence, I put 2 for the y. To get the corresponding x value, you rearrange, transpose the 3 to that side, and you have x is equals to y plus 3. So y being 0, 0 plus 3 is just 3. That is the corresponding image of A. That is the image of A. That was Prelim Eastern Cape 2017. Here's another question. We're given the function f of x is equal to a over x plus p plus q. Now we're given a couple of pieces of information. The domain is such that x is real, but x not equal to minus 2. Domain is such that x in real, but x not equal to minus 2. Therefore, p is equals to minus 2. That is the deduction from this piece of information. Next up, they say y is equals to x plus 6 is an axis of symmetry. For the axis of symmetry, we have 2 of them. Axis of symmetry. There are 2 of them. We have y is equals to minus x plus p plus q. Then we have y is equals to x minus p plus q. This one is the axis of symmetry with a positive gradient. So it corresponds to this one. Therefore, this implies y is equals to x, but we just said p is minus 2. So it's minus 2 plus q. But when we were given the value of that, it said it should be equal to x plus 6. So this is x plus 2 plus q. Transpose the x, you're going to get 6 is equals to 2 plus q. Therefore, q is equals to 4. Therefore, q is equals to 4. The function is increasing in the domain. If the function is increasing, that would imply that the function was in quadrant number 2 and 4. Draw a neat sketch of the following. If function is increasing, then this implies A is negative. This implies quadrants 2 and 4. This implies quadrants 2 and 4. A neat sketch of this is going to be the first asymptote is at x is equals to minus 2. The other asymptote is at y is equals to 4. Let me create more space. First asymptote is at x is equals to minus 2. x is equals to minus 2. The other one, q, was at y is equals to 4. They say the function is increasing. If it is an increasing function, then it is in quadrant 2 and quadrant 4. This is the corresponding function for this graph. That is the corresponding function for this graph. Your sketch must include the asymptotes, if any. We did include x is equals to minus 2 and y is equals to 4. And then the shape, obviously, the shape, when they say increasing, they wanted us to show a recognition that NA had to be negative. Therefore, it's in quadrant number 2 and quadrant number 4. Okay, I'll do this. Let's do another question. This question is coming from KZN 2017, the prelim, paper 1. The graph is drawn for us. I'll just reproduce it here. It's got an asymptote. This is the origin, y, x, and another asymptote at 2. Then there's a linear function that is passing through there's a point A right here, function f, then this is function g, the graphs of f and g, f which is 3 over x plus 1 plus q, and g which is equals to mx plus c are sketched below. A is a point of intersection of f and g. A is a point of intersection of the two graphs. G intersects the vertical and horizontal asymptotes respectively. G intersects the asymptotes, vertical as well as horizontal. But in f of x, they give us f of x is equals to 3 over x plus 1 plus q. The first thing we need to deduce is x plus 1 is equals to 0, x is equals to minus 1. This is the value of this vertical asymptote. So x is equals to minus 1. That means this point is minus 1. The linear function therefore passes through 2 points. Those 2 points are this one, where it's minus 1 and 0, and this point which is 0 and minus 0 and positive 2. So we have g of x is equals to mx plus c, but passing through 2 points, which is minus 1 and 0, and a, which is 0 and 2. Write down the value of q. The value of q is 2. Q is equals to 2. Why is that so? Because it's the horizontal asymptote and it's passing through right there. So the value of q is 2 for 2 marks. Determine the equation of g. The equation of g, we're going to use these 2 points. I can solve it simultaneously, so I'm going to do two ways. Solve simultaneously, or I first get the gradient, then I substitute. So y is equals to mx plus c. Using minus 1 and 0, this means 0 is equals to minus m plus c, equation number 1. Using a, which is 0 and 2, that means I have 2 is equals to c, equation number 2. Substitute equation number 2 into equation number 1. That means 0 is equals to minus m plus 2. Therefore, m is equals to 2. Therefore, g of x is equal to 2x plus 2. That is one way of doing it. Another way of doing it is to first get the gradient m. So gradient is equals to 2, this 2, minus 0, divided by 0 minus 1. 0 minus 1, minus 1, which is going to be 2 divided by 1. The gradient is equals to 2. So now I'm looking at y is equals to 2x plus c. All I need to do now is substitute one of the 2 points. I'm going to choose A. 2 is equals to 0 times 2 plus c. C is equals to 2. Therefore, g of x is 2x plus 2. Two different ways of getting exactly the same answer. Two different ways of getting exactly the same answer. Then calculate the coordinates of A. Calculate the coordinates of A. Coordinates of A at point of intersection. At point of intersection. F of x is equals to g of x. So the equations of the two functions are equal. The equations of the two functions are equal. Visually, we can analyze. The graphs are intersecting at 2 points. The graphs are intersecting at exactly 2 points. This point here and this point here. So we're going to get an equation that gives us 2 solutions. And we're going to decide which one suits. A has to have the positive x value. So f of x, g of x is 2x plus 2. F of x was 3 over x plus 1 plus 2. Start by transposing the 2. So we're left with 2x is equals to 3 over x plus 1. Multiply 2x squared plus 2x minus 3 is equals to 0. Let's crunch that. The first x value is equal to minus 1.82 and the other one is 0.82. Those are the values of x. So this one that we highlighted right here is the negative one, and this one will be the positive one. 0.82. So at A, x is equals to positive 0.82. The corresponding y is equals to 2, 0.82 plus 2. This is 1.64 plus 2. Therefore, y is equals to 3.64. A is 0.82 for x and 3.64 for y. Lastly, a transformation. If the graph of f is shifted 2 units to the right, we said shifting to the right actually has a negative effect in terms of x. So this is going to be, let's call it h of x is equals to f of x minus 2, shifted 2 units to the right. So you use functional substitution there. F of x, which was the hyperbolic function, this is 3. Wherever there's x, we remove the x and we put x minus 2. So x minus 2 plus 1 right here, plus a q of 2. The result, which is h of x, is equals to 3 over x minus 1 plus 2.